All right, so let's take a look in another example. And basically what we're going to do here is the same thing like we did in the previous one. We're going to focus on creating supportive edges, make sure that we have even spread of topology. And in the end, we're just going to redirect the edges so that we can maintain our corners here, here, and also on this side as well. All right, so let's begin with adding supports. So let's add a supportive edge here, and let's add supportive edge here. Then let's go out and even this like so. And now we can decide here, do we want to keep this loop as our corner, or do we want to convert it into a, let's say, square corner like this? So that really now depends, because also what I forgot to mention last time is what we can do is just add insert edge loop tool and create the same situation like this. Because in previous video I said that we would need extra edge loop on the inside, and basically we will do the same thing in this way. So that looks now like this. And also you maybe recognize that here inside now we have our square corner. And again, that also means that in case that we just select this loop, that in case that we already had square corners, and if there is room, we can just offset it on the outer side, and to get a corner like this, in case, like I mentioned before, we need this loop on the outer side. And again, just a small note that I maybe forgot to mention last time. All right, so our next step is going to be even distribution of edges. So let's now add that. Just make sure that everything is even, like so. And yeah, now we can preview and we can see that we are getting closer. And the only thing now that we need to do is we need to tighten up these edges. So these are now solved. Now we need to solve this one here. So let's connect this to here, and then basically redirect again this edge to here. And again, this is a very standard connection we talked about before, and we are going to use it quite a lot. And basically what it's happening is that we need to have an edge loop here around. And for now we do not. So if I now again select my multicut, you will see that the loop is flowing the wrong way. It should flow like this around here, but it's actually not flowing. So we need to redirect this one to here, this one to here. And then like we mentioned before, if we delete this, we're not creating much. We just need to then redirect them. So redirect this one to here. They need to lead somewhere. And then we direct them to here, and then just delete the remaining. And let's do the same thing on the other side. So just connect this one to here, and then connect this one to here, and remove these parts. And basically now when we check, we actually got our edge loop that we wanted, that it was basically edge loop like here. And if I now select this ring, you will see that edge loop is now correct. And now finally what we can do is just fine tune this a bit. So I maybe push this to the side, push this here, like so, and maybe we can fine tune also this a bit. Now this is now a bit finicky, but if you want to have, let's say, a nice, what I'm trying to do is select this part, nice looking mesh, then yeah, we can do this as well. And let's move this aside a bit, and maybe like this as well. This we can push to the side, and this we can push to the side, so that it's following sort of this line right here. And yeah, so I think that will do. And maybe here we can also even it out a bit. And what we could do is maybe slide this one here, scale it. And again, like I said, this is just really fine tuning, which in general it's not necessary, but since we're here, we can also show that as well. All right, and if you want to go even further, let's say if you want to even out these loops, you can just connect it like this and then delete the parts that are not even. And then there we are. All right, so now we have this corner sorted out. And let's say also I would like to mention one thing here that it's sort of important, is that it will also depend on the optimal distance, how much of a curve we want to have here. So for example, this here and this here looks more or less the same, so I would say that's fine. And if, let's say, we're looking at it from far away, this still should look sharp. If we make it too sharp from here, and this is, let's say, an object that it's not in our close-up shot, so let's say it's part of a kit bash or something that it's shown from distance. Even from distance, it should appear that it has so much of a curvature, just a little curvature here. because even if it's here super sharp, from very large distance, it might appear that it's not receiving any highlights in the render at all. So it might look very, very sharp. So this is something to take, just something to keep in mind. And also one thing I would like to mention is that, again, if we have a super close-up shot, for that case, we would also maybe add more divisions. So for example, we now added this much, and if we would do even closer shot, then maybe we would subdivide it even more like this, just so that we have more polygons to work with, and then we can define that sharper corner even more. So again, just a small tip there. And to finalize now this area here, so basically what we can do is maybe just slide this here and maybe slide this right here. And again, if we check, we should have the same curvature here, here, and here. And yeah, maybe a bit more inside, like so. And yeah, there we are. So if you really want to now check how it's this performing, we can actually again add a deformer. So let me just Control E here, add extrusion, and we can add 2 divisions, preview this, and let's go to deform, and let's go to nonlinear, and let's add a bend deformer. And there we are. So I will just check it here, and in general, everything looks in order. So we don't have any pinching, we don't have any deformation, and I think that this is enough of a curve that we can preview this. If you're going to go too far, if you go here, let's say, for that we really don't have enough divisions here. Again, we would need to have much more divisions if we want to preview on this strong curve. So for, let's say, this curvature, this is enough division. So it's the same thing basically as with the cylinders. When we work with the cylinders, we want to have enough sides because we are working with a strong curve, and without enough sides. So let me just show you what I mean. You see basically what is happening is that this polygon doesn't simply have enough geometry to smoothen itself out. So then you will see a lot of deformation here. So yeah, for that we would need a bit more geometry here. But in total for, let's say this, I would say that we are just fine. All right, so let me just go a couple of steps back where we basically have this shape. And I would like to also show you a couple of other things since we already talked about it. And let's see how those options perform here. So let's say that we would like to create a situation where we have something like this. Or even if we select the number of segments with the chamfer, let's say something like this with maybe, let's say two segments, or we can actually control how much of a curve we have like this. And basically what is happening, again, we have 1 and then 3. So basically this 3 to 1 connection, and then I would just delete this and then maybe connect this vert to here. And then, like I mentioned, we have this 3 to 1 connection. And what is happening is that now we can add more loops here, but the problem is we can also actually maybe do it before. So let me do it in the middle so it's maybe more obvious what the problem could be. Because this might also be a solution in some situations, and those situations can be very limiting, so it's not going to work always. So even though that this is correct, so we have a correct topology here, and there is nothing really wrong with it. We still have our curve here. We have a curve. Basically, we have a loop here, a loop here. The problem is that the loop is going to break here on this, let's say, diamond-looking polygon. And basically, the problem is going to be shown again on a curved surface. So again, if we just extrude this and add 2 divisions. Since we're already talking about it, it probably maybe crossed your mind that why are we not using, let's say, something like this. But like I mentioned, it really depends on a surface, because not every time it's going to be, let's say, a solution. So we're gonna just need to play around and try and find proper flow for what we need. So you see what is happening here is that we have this little highlight. Let me just maybe do a bit more of a bend here. So you can see clearly this highlight right here. So basically there are a couple of reasons for that. First reason is that we have this pole right here directly on our curve. So this is our general curve and it's directly in its way. So basically what is happening is that instead of highlight going in one direction, the highlight is now breaking here. So this is now the highlight, and that is why then you will see this as a like small lump right here. So it should always be, let's say, continuous flow. So what we can do, maybe just to give it a bit more pressure off, we could maybe slide some of the points away and maybe even it out a bit. So this will maybe give a bit more pressure off like this. It's still going to be visible, but maybe not as much. But like I said, it's really going to depend on a specific situation. Maybe sometimes also if let's say that the curve is different, so let's say that the object is lying on a different type of curvature like this, maybe it's not that much shown because there is not much deformation in that area like so. But again, if it would be maybe here in the middle, then it would be much more shown. But for now, maybe it's not that big of a deal. And especially maybe if we just release some of the tension from this area. Like so. So just to summarize, basically what this means that whenever you have evenly spread edges, that just means that it's going to be less of a chance that there will be any sort of deformation shown on the surface. If you really want to highlight, let's say, specific areas, then yeah, then we need to have edges close like this. But I just wanted to mention this as an alternative because we were talking about, let's say, redirecting edges in this way. And just again, if it's crossed your mind, I just wanted to show that. Let me just undo here a couple of steps. So yeah, what I was talking about is that I just wanted to show this as an alternative because in some situations it might work, in some situations it might not. It will just depend on how it's behaving on a specific curve. So if it's performing good, that there's no deformation, it can stay. And if it's causing deformation, like in our case, then probably we need to search for different solutions. But yeah, I think more or less this is all what I wanted to talk about in this video. It's again a very simple example. And now we can go ahead into the next one. And also what I'd like to mention is that I will give this project file as a download, so feel free to play around with it and see just how different edge flows affect the surface, because this is a very important topic and we are going to cover it more in the future for sure. But yeah, I think in general that this would be it for this video. So thank you very much for watching and I'll see you in the next one.